and then we'll move to the DSA. Have you like completed DSA?
Not yet.
Okay. And you find it like a little challenging?
Yes, a little bit.
It's just too much of concept, this algorithm, that algorithm. Just too much.
Mm.
It's not like general topics that you can just read and remember, like data mining
Yeah.
and data warehousing. You have to really remember the algorithms and stuff. So I have been making slides for all the topics in the syllabus. You must have seen at the bottom of the screen. I put some content already, but what I would like you to do is like when you are studying any particular topic, okay, of course at that point of time it will be fresh in your head. So maybe you can make some notes on those slides. So let me show you.
Okay.
Uh, Yeah. So see, this is this entire set of slides, of course, after the blue one ends, is in the order of how it is there in the syllabus, which is this one. Okay, so any topic that you study from here, you can just directly go to that slide and add some content. So initially, I've already put content, but like towards the later ones, the content is not like implementation of multiple queues. You can see all of these guys; these are like empty right now.
Okay.
So then will be useful for us to recap them at the time of examination, because I don't think there are very many blue slides. So you will definitely have some time left, and then it's I think it's always good to look at least and have an understanding of the other topics which are there. So in case if it comes in exam, then we can answer them,
Yeah.
because these are not enough. I feel that these are not enough. Whatever questions are present here, there are high
Did you put
chances that. Go ahead.
did you put the assignment questions also?
Yeah, yeah, it's already there. So all the blue sides
Okay.
contains assignment questions as well. Assignment also hardly there are 4 or 5 questions.
Yeah.
We don't have that many. So blue slides include both, but I can see there are other topics also. For example, hashing and stuff. There's no question about hashing. Scapegoat trees. You never know. They might give you like on short notes. Depth first search is there, but breadth first search is not there. You never know. They might give you breadth first search this time in exam.
Mm.
You can't say, right? The Kruskal's algorithm is there, but Prisms is not there. The Dijkstra's is not there. Acyclic graph is not there. So there are quite a few topics where which is not present in the assignment or on the question paper. At least it'll be good to read about them. So even if it comes, at least we can make some content out of them. Not saying we
Yeah.
have to like remember everything, but good to read if when we have time left. So yeah, like I said, when you are studying these topics, just go to that slide, search that slide, and just add the content. Okay, and I'll do the same
Okay.
when I'm studying any particular topic. The reason I'm putting them on slide is that when I study a topic, it's fresh in my head, and I can just uh, put the content there. Okay, so let's begin. Without further ado, so we were on inheritance, but I think we'll leave that because it's not part of the blue slide. We already know what inheritance is. We'll directly go on the polymorphism and its advantages. So we discussed about polymorphism was poly means many, morphism means forms. So an object that can take many forms. It can be achieved via overloading and overriding. And overloading is making a function do multiple things by just changing the signature of the function, passing different parameters. Overriding is making the function do something else by overriding the function in the child class. What are the advantages? Let's see. It tends to reduce the pairing of multiple functionalities, and it allows programmers to reuse, evaluate, and execute programs and forms I don't know what written once means here. 1 second. Advantages, polymorphism, Java. So did we cover reuse? Yep. So it's just too much. Reduces coupling between different functionalities. Supports. Can you check if there's there in the book the advantages? Maybe you can take it from the book.
Yes, I'll check.
Okay. So add it there. Don't have to do now, but add it. I'll assign it to you. See if there are other advantages in the book. Yes, please add them. Okay. So code reusability is what I understood by this. Support single variable name for multiple data types. So yeah, we saw that in the when it was used with multiple functions, we were using the same variable, but the data types were different. Okay, static polymorphism and dynamic polymorphism. Static polymorphism is a linking of a function with an object during compile time. It is achieved through the method of overloading. So it's a linking of a function with an object. This is at runtime. This is at compile time. This is at runtime. In this, the compiler doesn't determine the method to be executed. JVM that performs. It's the JVM that performs the process at runtime. Okay. JVM performs the process at runtime. So static polymorphism is a linking of a function with an object, and dynamic is compiler doesn't determine the method to be executed. JVM performs the process at runtime. So here JVM performs the process. Here linking of the function with an object during compile time and is achieved through overriding. Okay, this I think we can easily write different functions doing different things, overloading the same function to do different things. Moving on, use of super keyword also I think we did yesterday. On use of static method also we do. Where were we actually? Explain why. This is also we did. We didn't do this, right? No, we also did this.
We
So
stopped at
where?
data types.
Yeah, you're right. Okay, here it is. So we were doing non-primitive, we did arrays and stuff. Why don't I just like that? Okay, example program with Java class. So we have to make the previous slide highlighted also. Example program with the Java scanner class. Okay, so it'll ask us about the example program with the Java scanner class. We'll import the scanner and take the input. Let's write it. Let's practice it. Maybe that'll be better. So IntelliJ. I'll do it once, then I'd like you to do it. So what is the name? Main function. Say example. Okay. So inside that we know that we have to do public static main, and then we have args, and then we have string. Where does this array go? Go here, or does it go here? It goes here. Okay. Why it's complaining? Why is it complaining?
Public static void.
Yeah, you're right. Cool. Who is not returning anything? Okay, so we have to import the scanner class. So we'll import it. Import java.util.scanner. And let's try to do it without looking first. So we have to basically instantiate this scanner class. So data type will be scanner. You can call it input equals new scanner, and then it's the system.in. And then we ask the user to print something. So that'll be system.print.ln .out .println. Enter your message, and then input dot next line. Okay, and I think to hold it in a variable. Int message equals string here. Sorry, not int but string. And then system dot out dot println. Your message is plus sign message. See if that works. You have to close also scan, right? Input dot close. What is complaining? Code inside finally will always say string cannot be converted to a number. Oh, cannot be converted to a number. Okay, so let's look at the example. So we took, oops. So we imported scanner, which is fine. Inside of this, you have string args, which is fine. Scanner input new scanner system dot in, fine. System dot out println enter your message. Takes input from the keyboard. The string name is correct. Is it because I put ln? I don't have to use new line. And then string message equals input dot next line, which is what I did. String system dot out dot print ln my name is so and so, and what it's the same thing. What's the issue? What is the problem?
It looks like you're running another class. It says
Mm,
exception handling at the top.
where? Yeah, you're right. You're right. And it's selected here. So example, run. Yep, that's fine now. Thanks. Cool. That works. Okay, I'll stop the share. I'd like you to do it. You can share your screen.
Okay.
Scanner class, I think, is the most important because I think in most of the program you get to use it while taking the input.
Can you see my screen?
Yes.
Oh, you can see my editor, right?
Mm-hmm.
Okay. Okay, so first import scanner.
Okay. I don't think there's a space after string, is there? Probably doesn't matter. I don't know.
Then you have to initialize the scanner.
Yeah. It's not. Is it called initializing? It's called instantiation.
Okay, yeah,
Yeah.
instantiate the scanner.
Instantiate means when you create an object of a class. Initializing means when you're declaring a like initializing a variable or something. What does system.in does?
System.in, it's for taking input, right?
Yeah. Yeah.
And then read the message.
Hmm. What does next line does do?
It gets the next line of input.
Okay. Yeah. Fine. Perfect. Taking too much time.
It's slow because I'm sharing my screen, I think.
Okay. Okay, perfect. Great. So we've learned that. We'll probably practice the sums in the next session, like towards the close of the exam, like when the exams are nearby. Reason for that is we won't do it every day, and the reason for that is because if we are practicing it a day or two before the exam, there's a high chance of us remembering that. Yeah. Hi, Ashish. Good evening.
Hi, good evening. Sorry to join a little bit late.
I'm glad you joined. That's more important. It's okay.
Yeah, actually, I'm preparing. I was already looking into your old videos for the uh, computer organization.
Okay. Okay. That's good. All right. So we go with the exception and its causes. So what is an exception? Exception is an unwanted or unexpected event which occurs during the execution of the program at runtime that disrupts the normal flow of the program's instruction. When an exception occurs within a method, it creates an object. This object is called exception object. It contains information about the exception, such as name and description of the exception and state of the program when the exception occurred. So, exception is an unwanted event that occurs during the flow of the program, and it breaks or interrupts the flow of the program. And in case if you have handled exception, then your code will continue to run. But if you haven't handled it, then the code will cease to execute. And when an exception occurs, it gives us an exception object which contains the name of the exception and details and information about the exception. Causes in like invalid user input. Remember, we were doing C programming, then we were doing some causes. So, causes invalid user input, device failure, loss of network connection, physical limitation like out of disk memory, code errors, opening an unavailable file, the JVM has run out of memory, invalid user input, device failure, device fails, loss of network connection, physical limitations, code errors, opening an unavailable file, and JVM has run out of memory. So Ashish, I won't ask you to recap this because I understand you would want to keep your stuff that you're going to give exam for fresh in your head. Okay.
Yeah, okay.
Yeah. Or do you want to go over this?
So you
It's
want me to
okay,
read
right?
it out? That's fine. Yeah, that's
No, no,
fine.
no.
That's fine.
I'm saying that you want it. When is your exam?
Tomorrow?
Tomorrow. Okay. Okay.
Yeah, but yeah, that's fine. Like
You
till when
can.
we are going to conduct this session? Like today's session?
So
Any idea?
till 7 we'll do Java, and from 7
Mm-hmm.
to 8 we'll do DSA,
Okay.
algorithms
So
and data structure.
okay. 7 to 8 will go for the DSA.
Yes, yes. So till how long you'll be able to be with us?
Maybe I can join at 7. Like DSA is the most difficult part, I guess.
Okay, no problem. So do you want to join back at 7?
Yeah, yeah, obviously.
Okay, awesome. I'll wait for you. Excellent.
Thank you, man. Yeah, yeah.
Okay, bye. Bye.
Right.
Okay, so Sumaya, please tell me about what is exception and what are its causes.
An exception is an unexpected or unwanted event,
Yeah.
and it's caused by. It could be caused by programming error
Mm-hmm.
or uh, or a system failure.
Yeah. System failure, unwanted event, sorry, invalid user input, uh, sys- system crash, network connection got failed. What else? Program code error, like I have written some buggy code That could be a cause of exception also. And when the exception occurs, what data is created? What data type is created?
Exception object,
Yes. So what does it contain?
an error message.
Yeah, so basically it contains all the information about the exception, like the name of the exception, the error message, all the details. You can always print that and see. When you do catch, under catch, after the class name, you have the E variable. You can print it inside of the catch and see what's inside of that.
The stack trace, you can print that.
Yeah. Invalid user input, device failure, loss of connection, physical limitation like out of disk memory, code errors, opening an unavailable file. If you're trying to open a file that doesn't exist, you will get an exception. And then Java virtual machine has run out of memory. Now, why proper exception is handling is necessary? Well, separate error handling code from you've written this or is already there?
I added it.
Okay, good. Separating error handling code from regular code, exceptions provide means to separate the details of what to do when something out of ordinary happens from the main logic. Propagating error up the call stack. So I think there's no need to put second advantage. How can we make it better? Propagating errors up the call stack. Should provide exception has have an ability. So this way we shorten that. Of course, in the examination we can expand it, but here it's better to be more precise. Exceptions provide means to separate the details of what to do when something out of ordinary happens from the main logic of the program. Okay. Propagating error up the call stack. Exceptions have the ability to propagate error reporting up the call stack of methods. Grouping and differentiating error types. Because all the exceptions thrown within a program are objects, the grouping or categorizing exception is a natural outcome of the class hierarchy. An example of a group of related exception classes in Java program platform are those defined in java.io. I think it's too big to shorten it. Because all options exceptions thrown in the program, the grouping categorization is a natural outcome of class hierarchy. Okay. For group related exception classes in Java platform are defined in java.io. No need of Java platform. IO exception and its descendants. Okay. It's only three. Okay. Separating error handling code from the regular code. So exception provides separation of concern, which means they provide a means to separate the details of what to do when something out of ordinary happens from the program logic. Main logic of the program is too much. Main program logic. Propagating error up the call stack. Exception have the ability to propagate error reporting up the call stack. Of methods. grouping and differentiating error types, because all the exceptions are within a program, thrown within a program or objects. The grouping or categorizing is a natural outcome of the class hierarchy. An example of group layered exception classes are defined in java.io. IO exception is descendants. That is, IO exception and descendants. Okay, so may I go ahead and read that, and then we'll try to recap it.
Okay. Why proper exception handling is necessary. Separating error handling code from regular code. Exceptions provide the means to separate the details of what to do when something out of the ordinary happens from the main program logic. Propagating errors up the call stack. Exceptions have the ability to propagate error reporting up the call stack of methods. Grouping and differentiating error types. Because all exceptions thrown within a program are objects, the grouping or categorizing of exceptions is a natural outcome of the class hierarchy. An example of a group of related exception classes are defined in java.io, IO exception and its descendants.
Okay, so give me one of the reason why proper exception handling is necessary.
Exceptions help to separate the code that runs when something unexpected happens from the main code, from the main logic of the program.
Yes. Okay. And another one is the hierarchy that is available in the exception. So because all of the program code in an exception, when an exception is run, is an object, the classes, yeah, the classification of classes is a natural outcome of the class hierarchy. And the last point was related to the grouping of the, no, that was the grouping, right? Yeah, that was the grouping. And
Yeah,
then there was up the call stack. So yeah, when an exception is thrown, then what happens up the call stack?
it propagates the error up the
Yeah,
call stack.
correct, correct. So separation of concern, which is separate error handling code from regular code. So exception provides a mean to separate the details of what to do when something out of ordinary happens from the main program logic, and then propagating error up the call stack. So it propagates errors up the call stack of methods, and then grouping and differentiating errors, because all the exceptions thrown within a program are objects. So all exceptions are objects. Grouping or categorizing is the natural outcome of the class hierarchy. All exceptions are objects. Of exceptions. Natural outcome of class hierarchy. Okay. So separating the code from the main program logic. Then we have the grouping or classification, which means that because all exceptions are objects, the grouping or the classification, sorry, what was that? Grouping is a natural outcome of the class hierarchy. And then we had it throws the error up the call stack. Whereas when you separate the details, when you do something when out of ordinary happens from the main program logic, have the ability to propagate error reporting up the call stack of methods. Because all exceptions thrown within a program are objects, the grouping or categorizing of exceptions is a natural outcome of class hierarchy. An example of group of related exceptions classes are java.io, IO exception, and its descendants. Okay. Moving on, write a program to demonstrate the use of multiple catch clauses in exception handling. So multiple catch block, try, int, new int, a5, 30 by 0, catch arithmetic exception. System.out.print arithmetic exception occurs. Catch array index out of bounds exception. System.out.print ln array out of index bounds exception occurs. Catch parent exception occurs. Otherwise, print the rest of the code. So here we are declaring an array of type int, and it has maximum 5 elements, and we are trying to set the sixth element to be equal to 30 by 0. Arithmetic exception, array index out of bounds, an exception. Let's try it. So here, say we don't need the scanner. Public static void, main string and args, and then inside of this we have int array equals int. Where was the bracket? 5, is this correct? Something wrong.
I think you have to put new.
Okay. New array? Or
I
it be
think
array
it's
like
new
that?
int 5.
Fine. Let's see. New int 5, yeah. Correct. Then I'm gonna say array. I'll try to set the fifth item to be equal to 30 by 0. Okay, and then try. So what was that arithmetic exception? System.
No, the exception goes in the catch.
Oh yeah, you're right. So this was in try. Correct? Am I missing anything here?
Try doesn't have the brackets, I think it's showing an error there.
Okay. Okay, system.print .out.print ln arithmetic exception occurred, and again catch. This will be array out of bounds, array index out of bounds exception. Again e system.out.print ln array index out of bounds exception occurred. Why is it complaining? Typo. And again catch. This will be normal exception. Exception e system dot out dot print ln exception third system dot out print ln program flow continued. Now there's some error somewhere. Where is the error?
Exception. Catch exception. The spelling is wrong.
Okay. Do I need to import anything on top?
I don't think so.
Okay. Let's try it. Okay. So arithmetic exception occurred, and then program flow continued. Now I'd like you to try quickly.
I'm not able to share my screen.
Why not? I should be able to.
Okay.
Okay.
So try.
Int array bracket. Probably not a good idea to use the full word array. This should be a reserve keyword probably.
Get arithmetic exception.
That's E is the object, exception
Yeah.
object that we were talking about.
And lastly, get a normal exception. Any exception.
Hmm.
Arithmetic exception. And if this value is proper, then it will show our index out of bounds.
Yeah. You should put at least one line of code after the try catch.
Uh, Finally,
No, no, no. After line 16, just do a print of something. So we know that that code executed.
okay. Yeah.
Okay, good. 1 second. Okay, let's move on. So Maya, if I get admission in Canadian college, then party for you, inshallah.
Okay.
I have to score well in this exam to be able to get admission there. Okay, so going to the next one, example of exception handling. I think we've already done this. We don't really need to go over this, but we can read it once. We can easily explain. Various methods of exception handling are try, catch, finally, throw, throws. If you don't catch the exception using try catch method, the program will terminate at the a line where we get the exception. So this is what I was talking about. Like the whole idea of try and catch, we want to show that the next line executes. Like for example, if you don't put the line of code that you had put inside of try, if you don't put that instead of try, and if you just put that line and you put another line below, the next line which is here is not going to get executed because you're not catching exception. But if you're using try catch and if you put a line here, that'll always get executed because you're catching the exceptions. That's what we want to let people know. Okay, so the program will terminate at the line where we get the exception, which is will get terminated here if you don't use try and catch. Next line won't be executed. But if you do handle the exception, the program will catch the exception and continue to run. You can also pass exception in the catch method that will be catching exception of all types. Number format exception will only catch that exception type. In our case, we were using arithmetic exception. We were using array index out of bounds or index array out of bounds. Array index, right?
Yeah.
Okay. If we use the method finally after the catch, inside finally will always execute. They're not asking you finally, so it's fine. And if you want to use it, doesn't matter. Okay, moving on. Okay, so what is a package? I think package is a collection of similar type of codes. So like classes and all that. It's like a directory. Yeah, the package collection of similar type of classes, interfaces, and sub packages. So I think we should underline these guys. It's like a folder in a file directory. So class is a collection of package is a collection of classes, interfaces, and sub packages. It is just like a folder in a file directory. For example, when you write an application program in Java programming language, there may be many individual classes. You can place the related classes into a folder and name this folder for organizing these classes. Now it is called a package. So place related classes into a folder and name this folder. Give a name to this folder organizing these classes. This folder will then be called a package. Packages are used to avoid name conflicts. And write better maintainable code. Like in my document, all the PGDCA related stuff is here. All the assignment related stuff is here. Now here, I have all of the uh, the textbooks, PDFs. So helps me organize stuff, and I can easily go. And so this is similar. And so the word similar is important. Package is a collection of classes, interfaces, and sub packages, just like a folder with a lot of files inside of it. And to create a package, you basically group you put all the classes which are related into a folder. You name that folder, and now it will be called a package. And package is used for organizing the classes, a similar type of codes. And there's one more thing. Write better maintainable code. Yeah, avoiding name conflicts. Because if you have the same class name, you can't create another file uh, because there'll be a conflict. But two class files with the same name can exist in two different packages because they are in the same folder. I think it happens with the folder names also. That if you create the same name file here and you give another name file here in the same folder, it's not going to work. But you can place them in different files, different folders. So they avoid naming conflicts and write better maintainable code. So would you like to tell me what a package is, Sumaya?
A package is a collection of similar uh, classes, interfaces, and sub packages
Yeah.
grouped together.
Okay. And what is it used for? How does it benefit us?
It's used to avoid name conflicts and have better maintaining the code.
Okay. How would you create a package? Not the syntax. I'm not talking about the syntax. Yeah.
You have to declare the package with the
Hmm.
name of the package in the
Yeah.
file.
Yeah. Yeah. So basically, create a folder, name it, and then place the related class files inside of that. Now that folder becomes package. And of course, you have to write the syntax and all that stuff also, which we will study in a moment. So you can write an application program in Java programming language. There may be individual classes. You can place related classes into a folder, give a name to this folder for organizing these classes. This folder will then be called a package. Avoids name conflicts and write better maintainable code. There are certain accessibility rules for the packages. So let me recall. So I think public means that you can access it in if a class has been named as public, you can access it inside of the class as well as outside the class, within the package and outside the package. But if it's been but if you don't give any access modifier to a class, then it'll be default, which means it can only be accessed from within the class, outside the class, but within the same package. Then you have private. Private means it can only be accessed within the class. It cannot be accessed outside the class unless you use getters and setters. And then there is protected. So protected can be accessed within the class as well as outside the class. And I think it's within the same package. Let's see. So public can be accessed anywhere outside the package. Okay, good. Yeah, that was correct. Anything declared private can only be within the. Yeah, that's also correct. If you declared protected, then code is accessible in the same package, and its subclass parent in any other package. Yeah. So same or any other for protected. When you do not mention anything, access modifier is called default access modifier, um, which is visible into the subclasses and other classes, but in the same package. So let me put that here. Same package, subclasses in any other package. Do you remember this? Do you want to read it before we recap?
Yes.
Okay, go ahead and read it, but read it in a way that you're trying to remember, and then we recap it.
Okay. You can limit the access of classes, methods, and variables throughout packages by using access specifiers. The three main access modifiers, private, public, and protected, provide a range of access required by these categories. You can declare anything as public. It can be accessed from anywhere outside the package and inside the package too. Anything declared as private can only be seen within that class. If you declare it protected, then the code is accessible in the same package and its subclasses present in any other package.
Okay.
When you do not mention any access modifiers, it's called default access modifier, which is visible to subclasses and other classes in the same package.
Will you remember it, or do you want to go over it again?
I'll try to remember.
So, like you said, let me correct a few things here first. You can limit the access of classes, methods, and variables. Limit the access from within and outside. Cool. Okay, so give me some of the accessibility rules. What are the accessibility rules for the packages? First, give me the introductory statement.
Um, we have three access modifiers:
Mm-hmm.
private, public, and protected.
Okay, but what's the
And if
in generic? What is the use case? Like why those modifiers?
we use the modifiers to restrict access uh,
Of
of certain methods or classes
and
uh,
there's
and
one more thing.
variables.
Correct. So yeah. So basically, to start the introduction, you'll say that access modifiers are used to limit the access of classes, methods, and variables. Okay, and then you can start that. These are the access modifiers. Okay, so what does public mean in terms of accessibility? What's the rule for public?
If an item is declared as public, then it can be accessed from everywhere, from within its own package and from another package.
Okay, and if you don't give an access modifier to a variable, class, or a method, then what happens?
Then it has the default access modifier, and it
Yeah.
can be accessed from from subclasses and
Yeah.
from its own package.
Yeah. So the difference between the public and the default is that public can be accessed within or outside the package, but default can only be accessed within the same package. Of course, with the subclasses. Subclasses rules will always be there, but the key thing is whether it's going to be within or outside. So public is anywhere. But when it's public, it's public. It's outside the package, inside the package, doesn't matter. But when it's default, it has to be within the package. Then comes the private. So what happens with the private access modifier?
With private, you can only access it within the same class.
Is there a way to access it in a subclass?
Using getters and setters, you can
Right.
access
Is it going to be only within that package or outside?
only within the package in the same class.
Yeah. And what happens with the protected?
With protected, you can access it within the same package
Hmm.
and in subclasses outside the package.
Perfect. I think we'll remember it. Let's move on. So I think we should stop here, and then we should start with the DSA. Okay, Ashish is here. Welcome.
Yeah, thank you, man.
Yeah. So we'll start with the DSA. All the blue slides contains so they are placed at the start for convenience, and everything that we see in blue slides includes the exam papers and the assignments. Okay. So we'll start with the time complexity and space complexity. Whom did I give this task to explain about the examples? I think give it to Kritika, right?
No, no, no. It was Aniruddha.
Okay. Okay. No problem. Okay, so time complexity and space complexity. In general, there's always more than one way to solve a problem in computer science with different algorithms. Therefore, it is highly required to use a method to compare the solution in order to judge which one is more optimal. So, I'm just trying to say that for any problem, there can be more than one solution, and because there'll be more than one solution, we have to figure out which one is more efficient, which one is more optimal. So two such methods are time complexity and space complexity. So, time complexity basically, in simple words, decides what is the complexity of a particular algorithm in relation to time. Like how much time is this algorithm is going to take versus the other algorithm. Space complexity means how much space this is going to take. Okay, so when you talk about space, these are spaces of variables and constants. Okay, so now the definition: time complexity of an algorithm is a representation of the amount of time required by the algorithm to execute to completion. Okay, time requirements can be denoted or defined as numeric Tn, where Tn can be measured as the number of steps provided each step takes constant time. So when it's Tn, it means that each step is going to take constant time. For example, in case of addition of two n-bit integers, n steps are taken. Consequently, the total computational time is Tn c into n, where c is the time consumed for addition of two bits. And what is n? N is not mentioned here. Here we observe that Tn grows linearly as the input increases. So if you take a
And is
look,
the number of steps, no?
yeah, yeah. N steps taken.
Yeah.
So that's actually big and what's small and then
The big N is time for the whole N, and the small c is the time which is going to take and consume by the every step, and N is the number of steps.
it's a
I
bit
guess
confusing
that
because
could,
here there
yeah.
are two n's, and in the first example it's saying n steps taken. It's showing capital N. So it's a bit confusing. Anyways, okay, so we observe that Tn grows linearly as the size of the input increases. So if you try to remember, like get in your head that if there are like a graph where there is a vertical line and horizontal line, and you can draw a horizontal line in that graph, which means it's growing linearly. Okay, just show you linear graph. Time.
Like both x and y axis will be increased simultaneously.
Yeah, yeah,
Yeah.
yeah. This one. See, this is linearly increasing.
Yeah. Yeah.
Okay, so maybe we can put it also there. Where did it go? Yeah. Okay, so yes, that's the time complexity. Then space complexity of an algorithm represents the amount of memory needed by the algorithm in its life cycle. So let's do a recap. So one second, just put an animation to this. Animate. Okay. So Ashish, can you recall just the introduction of time complexity and
Yeah,
space
like
complexity?
basically every problem is can be solved in different ways. So
Yeah.
the problem solving is dependent. Like we can judge the uh, performance of the problem solving by two factors: the time and the
Yeah.
space. Okay,
Correct.
the time is then like the total time taken to execute the number of steps that are going to execute, and the space, it's a total number of space or the volume of space which is going to get used by the program to get it executed. In case of space, it's a space required by the variable and
Hmm.
the constants which has been declared in the program.
Very good. I think it's one of the most important questions, and I'm like 99% confident this question is going to come in the exam.
Yeah.
And it's because it's also asked in a lot of interviews. One addition to what the content you've shared with me is the use of word algorithm, because we all talking about data structures and algorithms. So when we
Hmm.
say the amount of time is a representation of the amount of time an algorithm takes to complete its execution, and the amount of space an algorithm takes to complete in it within its life cycle. Cool. And give me the example. Do you recall the example? What was the example?
Let's say like in the time, like we can represent the t capital
In
N
the addition of two
is a,
bits.
yeah, in the addition of 2 bits. Let's say there are n number of steps, and
Hmm.
the number of time taken by every individual step to get executed can be considered as a c. In
Yeah.
that case, the t of n will be c into n, which will grow
Yeah.
linearly, like as the number of steps increases,
Hmm.
then the number of time, like amount of time just going to get taken by the program is also going to increase linearly.
Awesome. Awesome. Great. That's the graph of your linear graph, and this is the big O notation n. This grows linearly. Okay, cool. Let's move on. So space complexity needed by an algorithm is equal to the sum of the following two components, which you already explained. It's the fixed part, which is the constant, and then the variable part. So a fixed part is a space required to store certain data and variables, simple variables and constants, program size, etc. that are not dependent on the size of the problem. Okay, so it's not going to be n; it's going to be always like a fixed number. It's not dependent on the size of the problem. But when you have some variables like n, m, whatever, that's a variable part. It's actually dependent on the size of the problem. Okay, so to just underline this, space needed by algorithm equal to sum of the following. Space needed. Space needed is equal to sum of the following two components. Remove the following. I don't want any unnecessary word there. Sum of the two components. Fixed part, space required to store certain data and variables. Okay. Not dependent on the size. They are not dependent of the size or on the size.
Of the size,
Of the size of the problem.
non
Will on be incorrect?
dependent. I think both are correct.
Okay, leave it then. It's space required by variable size totally depend on the size of the problem. Space required by variable size dependent on size of the problem. So in the upper part, the first one, there was no dependency on the size of the problem, but here there's a dependency on the size of the problem. So I think the key things to highlight in this, which we can make bold, is dependent on the size of the problem, and on the top, not dependent on the size of the problem. Okay. Okay. So then space complexity of any algorithm P is, we should break it into a line so it's more readable. Uh, okay, I don't have enough space here. Okay. Yeah. The space complexity SP of any algorithm P is P a P algorithm is SP equals A plus A must be the constant, I guess. SPI, where A is treated as the fixed part. So A is the fixed part here. A is the fixed part, and SI is treated as the variable part. Okay. Why it's called SP then? It should be okay. Which depends on the instance characteristics I. Okay. Following is the example. So sum of P and Q, step start, R equals P plus Q plus 10. Stop. Here we have three variables P, Q, R, and one constant SP equals 1 plus 3. And now space is dependent on the data types of the given constant type and variable, and will be multiplying accordingly. Okay. So space complexity, space needed by the algorithm is equal to the sum of the following two components. One is the fixed part and second is variable part. Fixed part is dependent on the size of the problem. Sorry, it's not dependent on the size of the problem, and the variable part is dependent on the size of the problem. So space required to store certain data and variable that are not dependent on the size of the problem, and variable part is a space required by variables whose size is dependent on the size of the problem. Example: recursion, stack space, dynamic memory allocation, etc. Like sometimes we declare an array which is not of a fixed size, it's dynamic array, which can grow and reduce in size depending on the requirement. So space complexity SP is equals to A plus SI. Should this be SI or SPI? It's so confusing. Somebody could check it.
SFI.
Yeah, I mean, I'm getting confused where I've copied. Sometimes the book is like place I've copied is not right. Space complexity and type complexity. That's where I got it from. No. No, here's where I got it from. Let's see. Where is it? On. No. Yeah, this is the one. Why are you calling SPR? Okay, anyways, we'll check that later. Okay, A plus SPI, and A is treated as a fixed part and SI is treated as a variable part. And this is an example. Sum, start, R equals P plus Q plus 10. 10 is the fixed part. These guys, P and Q, are variable part. And that's it. Okay. So, Maya, do you want to recap this? So, tell me a little bit more about the space complexity. What are those two components that it's dependent on?
Sonia is not here, I guess.
Oh, she must have gone for prayers.
Yeah, correct.
Okay, go on. You go on.
So the space complexity depends on the two parts of the program. One is the constants, and the another one is the variable which has been declared in the program. So the T of no, the S of P can be calculated as what is that? The formula. I don't remember the formula.
A plus. It's
A
okay.
plus SP of I, like instead of SP of I or S of I, whatever we decide.
Yeah.
Where A
But
is the part of the like
which
number of
part?
the constants. It's
Yeah.
a part of the constants that has been
Hmm.
declared in the algorithm, and S of I is the
Variable part.
variable part.
Correct. So, Ashish, it's a good thing if you forget, because when you are corrected by someone,
Yeah,
then your mind registers that point, that kind of in your
yeah,
head, and then you're able to recall that.
you're right.
So I
You're right.
remember so many instances where I keep forgetting. Remember, you were there on the call on the night before the exam where I had forgotten what was the manager where we request locking, and then Sumaya corrected me that it is
Hmm. Yeah, yeah, yeah.
concurrency control
Concurrency
manager.
control manager. Yeah,
Correct.
I do
I
remember
can't
that.
forget that now. I can't forget. I'm sure you can't forget that either. So
Yeah,
this is
me
the
too.
advantage of this group study. In less, if you had to study yourself, I'm pretty sure you're going to maybe fiddle with your phone or go somewhere else. But if you are being part of group study, you can't go anywhere, you have to
Yeah,
stay. So it's like
correct.
2 hours of complete focus. And at the same time, because we are discussing these things, then it's getting registered in our head
Yeah,
and
like
stay
it
longer.
just get printed on your mind.
Yeah, see, you remember so many things from yesterday's discussion also. You told
Yeah,
me fixed and variable, you remembered that we discussed that yesterday,
yeah,
right?
yeah.
So that's why daily is important, because when you sleep overnight, that stays in your some, at least some part of it stays in your long term memory. Next day again you revise, then more part goes in your long
Bro,
term memory.
you won't remember, like you won't believe. Like last
Yeah,
semester, we did group study for the computer organization, and right now
yeah,
I went through all those old videos where I was asking you lots of questions, and we were
yeah,
discussing a lot of things. When I was going through those videos, like it's like, yeah, man, I remember this. I can.
yeah.
It's not going to take much time for me.
Correct, absolutely. This is like a revision.
Yeah, 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 yeah.
Awesome. So moving on. So difference between time complexity and space complexity. So the first is, as the name suggests, the time complexity calculates time needed. Space complexity calculates memory space needed. Um, Time complexity counts time for all the statements, counts memory for all the variables, including inputs and outputs, and plus the fixed part as well. uh, Depends mostly on the input data size. This depends mostly on the auxiliary variable size. More important for solution optimization, less important with modern hardware. So we discussed yesterday that modern hardwares, have that much of space. So even if you goof up with that, it's fine. Time complexity of merge sort is O n log n. That's a bigger notation. N log n. That's an example of that. And space complexity of merge sort is O n. Okay. Can you read this once again?
I think Sumaya is back.
So Maya, would you like to read?
Okay. Time complexity and space complexity difference. Time complexity calculates time needed, space complexity calculates memory space needed.
Okay.
Time complexity counts time for all statements. Space
Mhm.
complexity counts memory space for all variables, even input and output. Time complexity depends mostly on input data size. Space complexity depends mostly on auxiliary variable size. Time complexity is more important for solution optimization. Space complexity is less important with modern hardware.
Right. Right.
Time complexity of merge sort is O n log n. Space complexity of merge sort is O n.
Correct. So time complexity, we already know the definition, calculates time needed. Space complexity calculates memory space needed. Time complexity counts for all statements, and space complexity counts the memory space for all variables, including inputs and outputs. This depends mostly on input data size. This depends mostly on auxiliary variable size. So input data size and auxiliary variables size dependence. Uh, More important for solution optimization, less important with modern hardwares. Time complexity of merge sort is O n log n, and this is O n. Let's try to recall this. So let me just hide this one. So Ashish, give me 1 point on the difference.
Time complexity calculates the time required for
Yeah.
completion, and the
Mhm.
space complexity calculates the space required to complete the instructions.
So you are kind of talking about the algorithms, right?
Yeah, yeah.
Okay, awesome. So may I give me 1 point?
Time complexity depends on the size of the input, and space complexity depends uh, on the size of
Auxiliary
the uh,
auxiliary
auxiliary
variable size.
variables.
size. Okay,
It
so
depends on
size
the
of the
auxiliary
input,
variable size.
yeah, size of the input for time complexity and space complexity depends on the auxiliary variable size. And another point is that the uh, example of was it merge sort? I think it was merge
Yeah,
sort. Merge
merge
sort
sort.
is big O notation O n log n for time complexity and space complexity. The merge sort algorithm
O of n.
is O n. Okay, and then another point is that
Yeah,
this is time complexity holds some importance, but space complexity doesn't because of the modern hardwares, which have enough space.
yeah. And
What
time
else? There would be,
complexity also calculates based on the all steps of the
yes,
program, and the space complexity. I don't remember the second point.
it calculates based on the variables, including all variables, including input and output.
Okay. Fine.
Okay,
I think we're done.
recap. Yeah,
Yeah.
recap. Time complexity calculates time needed. Space complexity calculates memory space needed. Time complexity counts time for all the statements. This counts the memory space for all the variables, even inputs and outputs. So all statements and all variables. This depends mostly on input data size. This depends mostly on the auxiliary variable size. I'll try to remember this word auxiliary from my uh, car input jack, where you put the music. There's an aux cable.
Yeah.
Yeah, you call aux, right? That
Yeah.
plays aux.
Correct.
So I'll try to recall this word from there. So variable we already know, and Ian was talking about the size. So here on the left, it's the input data size because in the time complexity, if you give more input which is variable, then it kind of multiplies and increases the complexity. But and here is the variable size, depending on how big the variable is. And more important for solution optimization, because we have to remember this word, solution optimization. Less important. This is less important with modern hardwares. And merge sort time complexity is O n log n, and this is O n. Okay, excellent. Okay, this is someone was supposed to write this, right?
I
Samaya?
think Kritika.
No, no, no. I think this
This
was
was done by Sumaya.
yeah,
Remember,
but
like, yeah.
somebody was supposed to change it. I know there is another step. This has been added. I don't know who's added it. Samaya, have you added this?
I added this because the question in the paper also says show all steps of the application of the algorithm. So
Mm-hmm.
Correct.
I think you have to show how the algorithm works on the example that they've given.
Okay, we'll take an overview of this, and probably just the day before the exam, we're going to go
Yeah, yeah.
ahead and do this and practice this, because then that's what we did last time also. All the problems related stuff we did one day before exam, so we can recall it. But yeah, we'll go through this. So it's saying that write an algorithm to bubble sort. Bubble sort is something like this, where you keep swapping the adjacent elements and keep going like that. So here it's starting from the fifth element. You're swapping this, then you're swapping this, then you're swapping this, and you're swapping this. You're only swapping if in case one of them is larger than the other. So here you have an array, and these are all the items you need to sort, and loop through the last element. Int I equals 1. Loop array to the last element. Okay, so go up until the last element, then loop to compare the array elements. So this is going to compare n minus 1. So n was, let's say, 1, 2. So n is what, 6?
Six.
0, 1, 2, 3, 4, 5. So there's 6 elements. So it'll go up until the yeah, of course, sixth element, because index starts from 0. So it'll go up until sixth element. 6 minus 1, 5. So what's going to happen is it'll start from 5 and it'll go up until the first element. So we're kind of going reverse. And then we are comparing if the fifth element is j minus 1 is less than or equal to the fourth element, and then swap it if it is. And then this value keeps on changing. So next time this 5 becomes 4. So we'll compare it with the 4 and 3. and then we'll compare it with 3 and 2, and so on and so forth until everything is swapped. And we're only going to swap it if they one of them is not in order. And then finally, once we have the sorted array, we go ahead and print it out. Show all the steps in the bubble sort. So again, we are doing it from the last step. So again, like I said, we'll swap the 0, 1, 2, 3, 4, 5, fifth element. So fifth element with the fourth one, and then fourth with the, okay, sorry, 1, 2, 3, 4, 5, 6. 6 with the fifth, fifth with the fourth, fourth with the third, third with the second, second with the first element. So you do all the swapping, you get all the numbers, second iteration, all of that. Yeah. I'm gonna take a 5 to 6 minutes of breaks. I hope you guys are okay.
Yeah, fine.
Okay, let's take a break. We have been
Like,
studying
is
since
it
last half an
possible
hour.
to pause your what do you say, the stream which you're doing?
We'll keep it on, and I'll be back in 5 6 minutes. Okay.
Okay, fine. Sumaya,
Yeah.
yeah, Sumaya, like, is it possible for you to give me at least 15-20 minutes of your time to explain ones and twos complement problem solving, which last time you explained us?
Um. Yeah. I don't remember two's complement so well, so I need to review that.
Okay. So just like tell me when it is possible for you. Like if you invest 10-15 minutes to get just revise and 10-15 minutes for us to explain, if possible.
Maybe I
Like,
can. Maybe I can do it right now. I'll check.
okay.
It's pretty simple. I can explain it right now in a few
Yeah,
minutes.
yeah, yeah, that's fine. Thank you. That would be appreciated.
Okay, 1 second. I'll share my screen. Can you see my screen?
Not right now.
Oh, I think Imran needs to show it.
Okay, we need to make you a presenter, I guess.
But one's complement is basically just flipping all the ones and zeros. So that's very easy.
Yeah,
Change
yeah.
the ones to zeros and zeros to ones.
Mhm.
And with two's
Can you do
complement,
one thing, Sumaya? Sorry, like rather than doing like this, I will send you a photo of the last semester question paper for the two's complement notations.
okay.
Maybe that would be easy. Like you can explain me. That's fine. Like two's complement. I know. Like we did it last time also. You took that session and you explained everything. Do the same, but right now it's not possible for you to stay on screen. Otherwise, it would have been better.
I can solve it and send you a picture.
Mm,
That
okay.
would be easy.
Yeah. So, like subtraction of minus 56 from minus 77 with the 8 bit including the sign bit in two's complement.
Okay, that will take a little bit of time.
Okay. Okay. Because that was only one concern which I just wanted to see. Because I remember last time the two's complement which you showed, like we need to add one at the end, if I'm not wrong, correct? For the two's
Uh,
complement, we need to add one. Like after doing
yes,
a
we need
one's
to add.
complement, we need to add one,
Yeah.
and if there is any extra parity bit after the 8 bit, then it will be considered as a negative number, correct?
Yes, if the parity bit is 1, then it is a negative number.
Yeah, but we did it for the addition, we never did it for subtraction, so I don't remember what needs to be done for the subtraction. Just explain me if you want. Like I'll get it because you explained that last time. I recollect everything.
So subtraction is basically the same as addition, but make the subtracted number negative.
Negative.
Yeah.
And how to make it negative? Let's say for the 56, the 8 character will become something like 56 to binary.
The parity bit will be 1 if it's negative. So
Okay.
you just make it negative and follow the same steps as addition.
Okay. 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 Fine. So in that case,
You're using two's complement, then to make it negative, you
let's
have to
say,
take three's
so
complement.
I already took a look, like 3 and 3 6. Like 56 in the binary is denoted as 1 1 1 0 0 0, correct?
Yeah.
And 77 is denoted as 1 0 0 1 1 0 1 1 0 0 1 1 0 1 1 0 0 1 1. So it needs to be 8 characters. So for 56, I'll add 2 leading zeros, and for 77, I will add 1 leading zero. So it will become 8 bit conversion, correct?
Yes.
And then I'll do a negation. No, negation is not required. So parity bit will be extra 1 at the start, correct?
The eighth bit is the parity bit. It's not an extra bit.
1, 2, 3, 4, 5, 6, 7,
Okay,
8.
I'm
So,
back.
okay.
Shall we continue?
Yeah, Imran, just one note point. Like once we complete all this, just end the broadcast, and I want Sumaya to be here only for 5 minutes to understand one
No problem.
concept.
No problem.
Yeah.
That's fine.
Thank you, man.
Yeah.
Yeah.
Okay.
Go ahead. Continue.
Okay. So now we go to stacks. Again, one of the key, I feel it definitely will come. So stack is a linear data structure that follows LIFO, which is last in first out. Just like when you go to purchase a ticket, ticket counter, like for a movie or something, which people hardly do, but just in case if you're in a mall or something, uh, then person who is at the first, goes out. Like person who was last in goes first out. Okay. So stack has one end, whereas queue has two ends, front and rear. It contains only one pointer, top pointer, pointing to the topmost element of the stack. Okay, so let's say you push one, and second goes, and third goes, fourth goes, and so on. When you want to remove it, fifth will go off, uh, fourth will go off, third will go off, two, and one, so on. Since our stack is full, the size of the stack is 5, and in the above case, we can observe that it goes from top to bottom when we were entering the new elements of the stack. Stack gets filled up from the bottom to top, just like your plates. When you put the plates, the last one you kept on the top will come out first. Okay, so last in, first out. So stack has one end, contains only one pointer, top pointer, pointing to the topmost element of the stack. So the key things to remember is that it's a linear data structure. It follows last in, first out principle. It has one end, and it contains the top pointer pointing to the topmost element of the stack. Okay. Okay. So Maya, you want to read this?
Yes.
Okay.
A stack is a linear data structure that follows the last in, first out principle.
Hmm.
Stack has one end, whereas the queue has two ends, front and rear. It contains only one pointer, top pointer pointing to the topmost element of the stack.
Correct.
Suppose we
Go ahead.
suppose we want to store the elements in a stack and the stack is empty. We have taken the
Hmm.
stack of size 5 as shown below, in which we are pushing the elements one by one until the stack becomes full.
Hmm.
Since our stack is full, the size of the stack is 5. We can observe that it goes from the top to the bottom when we were entering the new element in the stack. The stack gets filled up from the bottom to the top.
Yeah, the example I gave for movie tickets, I think, is not correct in this case because it doesn't follow the last in first out principle. But yeah, the plates example is
That's a
correct in this
queue.
case. Sorry?
That's a queue. You're
Yeah,
buying
that's a
tickets.
queue. Correct. The ticket is the queue. Queue is the ticket wala thing, and the stack is your plate example. Stacking the plates. Okay. Cool. So yeah, Ashish, you wanna go and read?
Yeah, absolutely. Fine. So a stack is a linear data structure that follows the LIFO. It's a last in first out principle. Stack has one end, whereas the queue has two ends. I don't know why they're talking about queue in here.
Sorry.
That's a,
Yeah.
uh, it contains only one pointer, top pointer, pointing to the topmost element of the stack.
Yeah.
Suppose
I,
we want to store the element in a stack, and let's assume the stack is empty. We have taken the stack of size 5 as shown below, in which we are pushing the element one by one until the stack becomes full. So in the
hmm.
first item, you can see one is pushed, then two is pushed, then we're pushing three, four, five. So since our stack is full and the size of the stack is 5, in the upper case, we can observe that it's going from the top to the bottom when we are entering the new elements in a stack. The stack gets filled up from the bottom to top. It's just like a bottle. Okay, like you can fill
Hmm.
it from the top only.
Yeah. Correct. And you can remove it from the top also.
Yeah, and removing also from the top.
Okay, so now it's time to recap. So I'll give 1 point and then you guys give me other points. Let me just remove this guy. Okay, so A stack is basically a linear data structure that follows the principle of LIFO, which is last in, first out. And now, Ashish, give me another point on this.
Stack pointer होता है.
Like, just think about difference between queue and
Yeah,
stack.
yeah, yeah.
You,
So the stack can be filled from only top, and
hmm.
unlike the queue,
How
like
many ends
queue,
does stack has? Think
it
about
has
that.
only one end.
And queue,
Stack has only one end, and queue has two ends.
which are the ones?
The in and out.
What does
No,
your
for this,
car have? What does your car front is called? Front,
uh,
and the back is
yeah,
called
front
rear.
and the back. Yeah,
Yeah, front
front
and
and
the
the
rear.
rear. Yeah,
Correct.
correct,
So you have the rear view mirror and all of that. So you can think of
correct, correct.
those terms from there.
Yeah. Now I'll
So
remind this like.
yeah. So stack only has one end. Queue has two ends, front and rear. And then tell me what is the point about the
Stack is
pointer on
full.
the stack?
Like the pointer
Where is the
starts on the
pointer
top,
in the stack?
on the top of the stack.
Yeah. So the pointer is pointing at the top of the stack. Correct.
Yeah.
So may I give me an example of the stack?
Uh, Stack is like a stack of dishes. Uh,
Hmm.
you add a new element at the top and remove an element from the top.
Okay. Cool. Moving on. Operations performed on a stack. The following are some common operations implemented on the stack, like push. When we insert an element in a stack, then the operation is known as push. If the stack is full, then the overflow condition occurs. Stack overflow error आता रहेगा ना वो तभी होता है जब like it's full and you're trying to push it. Like for example,
Yeah.
you create an array of a fixed size 5 and you try to insert sixth element. It's not going to work because it's a fixed size, so you'll get a stack overflow error. So that's pushing and inserting an element. Pop is deleting an element from the stack. If the stack is empty, means it has no elements in the stack. The state is known as underflow state. Okay, so overflow means it's already full. You're trying to push more. And underflow means there's nothing inside of it, and you're still trying to remove item from it. Is empty determines whether the stack is empty or not. Is full determines whether the stack is full or not. Peek is used to retrieve or fetch the first element of the stack. Retrieve or fetch. Okay. The first element of the stack or an element present at the top of the stack. It returns the total number of the elements available in the stack. Change, it changes the element at a given position. Display, it prints all the elements available in the stack. Okay, so I'm going to ask you questions. So Samia, give me what does push do?
Push is used to add an element to the top of the stack.
Okay. Uh, Ashish, if I want to display an element, what function will I use?
Sorry, I was not listening to you. Sorry.
No problem. So
Display.
for displaying, it's display function.
Display.
Okay. Yeah. What does Sumaya? What does peak function do?
Uh, Peek is used to view the top element of the stack.
Okay.
Get the top element, right? Get to retrieve.
No, that is pop.
Pop is to
No, I'm talking
remove.
about get or retrieve. I'm talking about peak. The
Okay.
peak job is to get or retrieve the top element or the first element from the stack. Okay. What does pop do,
Pop
Ashish?
is to remove. It's to remove the topmost element from the stack.
Okay. What happens in case if there are no elements in the array, you're still trying to pop? What will happen? What is that state called?
State. Empty stack.
Underflow state.
Underflow.
Yeah, underflow state of the stack because
Underflow
it
state.
doesn't have
Okay.
anything. You're still trying to remove it.
Okay.
Okay. So Maya, in case if the stack is already full and you're trying to put more element into it, what is that state called?
Stack Overflow.
Yeah. Then another function will be okay. So, uh, Ashish, tell me what function will you use to check if the stack is empty or not?
No, no, sorry.
Try to extract
Okay.
information from the content I'm giving you.
Okay, just repeat it again.
Yeah. What function will you use to check if the stack is empty or not?
It's just a check.
No. What is the word? What is the keyword I'm giving you in my question?
Empty or not.
Correct. Correct. So it will be is empty.
Is empty. Oh, okay.
Okay.
Is empty.
So Maya, what function will you use to check if the stack is full or not?
Is full.
Is full.
Yeah. Correct. Okay. So push, pop, is empty, is full, peak. Yeah. What function will okay? Sorry. What does count function do, Ashish?
Which one?
Count
Count. It will count the number of
elements.
elements in the stacks. Yeah, in
Yep.
the stack.
Okay. Change. It changes the
Change.
element at a given
Yeah.
position, and display prints all the elements in the available stack. So this operation performed on stack is actually in the question paper. So if you see here, says define stacks a 10 marks question, Ashish. So you just
Yeah.
prepared a 10 marks
Yeah.
question.
Wow, that's good.
Okay, so yeah, just think about all the actions you can perform on that stack. And if you do so, then you automatically remember the function. It's just a matter of describing what they do. It's simple like pushing, popping, is empty, is full, peak, count, change, display. You list down all of these, and that's it. Okay, moving on. Write an algorithm to reverse a string. So here the idea is to create an empty. So the main idea is to create an empty stack, push all the elements, and then pull all the elements. So when you're going to push it, of course, the first item goes in at the bottom, then second, then third, then fourth, then fifth, like we seen in the stack example. When you remove it, of course, they're going to come from the top. So the fifth one comes on top. Okay. So that will sit at the bottom. Then fourth one comes, then so on and so forth. So that's a way to reverse it. So the idea is to create an empty stack, push all the characters from the string into it, then pop each character one by one from the stack and put them back into the input string, starting from the index 0. As we all know, stacks works on the principle of first in, last out. After popping all the elements and placing them back to the string, the form string would be reversed. Create an empty stack, one by one push all the characters to the string, one by one pop all the characters from the stack and put them back to the string in form of an array. Steps is begin, read string, compute the length of the string, initialize stack, stack equals create stack, push characters onto the stack for I equals 0 to n minus 1. Push function, we already know it pushes the elements in the stack. Stack is the array, and this is the element, the ith element. Then pop the characters from the stack and put them back to the string. So for I equals 0 to n minus 1, uh, you hold the element by popping it out, and then you hold it inside of si, and the output reverse string s. Okay, so Maya, can you quickly read this?
The idea is to create an empty stack and push all the characters from the string into it. Then pop each character one by one from the stack and put them back into the input string starting from the 0th index. As we all know, stacks work on the principle of first in, last out. After popping all the elements and placing them back to the string, the form string would be reversed.
Keep going.
Step 1 begin, step 2 read string s, step 3 compute length of string n equals length. Step 3 initialize stack, stack equals create stack. Step 4 push characters onto stack. For I equals 0 to n minus 1, push stack si, pop characters from stack and put them back into the string. For I equals 0 to n minus 1, si equals pop stack, output reverse string s, end.
Yeah. So now I'm going to hide this. So first, Sumaya, tell me what's the concept when we want to reverse a string using stack?
So we add all the characters of the string onto the stack,
Mm-hmm.
and then
Into
pop
which
all
stack?
the
A stack which is full?
onto an empty stack,
Yes.
and then pop all the characters one by one and add them back into the string.
Okay. Now give me the algorithm for that. So I'll give you the first step. So first step is start, and then you basically create a stack, and then find out the length of the stack, and then what do you do after?
Um, Loop through the characters of the string
Yeah.
and add each character onto the stack
Using which method?
using push.
And what does push accept in parameters? What's the first and second parameter?
A stack and a string index si.
Si, for example. Okay.
Yeah.
Right. What's the next step?
Um, Next, you have to loop through the stack elements and
Mhm.
pop the elements.
Okay.
Um, Pop the elements and add them into the string starting from the 0th index.
Okay. What will be the equation when you want to pop it and hold it in a variable?
For I equals 0 to n minus 1, uh,
Uh-huh.
s equals pop pop stack.
Okay. Cool. Right. So read the string, whatever user has entered. I think we missed this step. Then compute the length of the string, which is n equals the length. So we hold the length of the string in n. Then we initialize the stack using create stack function. Currently, this is an empty stack; it doesn't have anything when we initialize it. So this is what I was talking about when you're saying initialization. Okay, so here we are initializing a variable, but there we are instantiating because we are creating an object out of the class. Push characters using push function. Pop characters, again same loop is the same for I equals 0 to n minus 1, and then holding it inside of si, passing the stack, and then we're printing the output. Okay, cool. This is the last question we're going to do, and then we'll call it a day. So algorithm to insert an element into a singly linked list. First of all, I want to know what a singly linked list is.
I remember yesterday's example which you have given. It's just like in doctor which is going to operate patients.
Yeah,
Yeah, singly linked list is something like just like a data structure which holds the data and the address for the next data.
very good. Yes, yes.
And the where it starts, it's called the head, and at the end, it's just data, no addresses available. So that's an end.
That's so. What will be the value of the column in which it stores the address for the last one?
To call, I don't remember that.
It'll be null.
None. Ah, okay,
Yeah.
fine.
So this will be null because there's nothing on the right, right?
Yeah, yeah,
So
yeah.
so the value will be
Makes
null.
sense.
So this is the so algorithm to insert an element. How will you insert an element? This is the original condition. So think that this doesn't exist right now. So this is the original condition. There are two elements, two nodes basically. This node has the value inside of it, and then this has the address of the next one. Same thing, value, and this doesn't have any address. This is the current situation. Now I want to insert another node. So first I'll create a node, and then I will use a pointer to point the head to this new one, because initially the head will be pointing to the old element, old node element. So now it will point to the new one. Okay, and then the address pointer will point it to the first element which was there originally. So coming back here, inserting a new element into a single linked list at the beginning is quite simple. We just need to make a few adjustments in the node link. The following steps we need to be followed. Allocate the space for the new node and store the data into the data part of the node. So these are nodes basically, and they have two parts. There's the data part and there's the address part. So allocate space for new node and store the data into the data part of the node. This will be done following statement. So use pointers. And when we were studying C programming, if you remember, we learned calloc, malloc. If you want to dynamically allocate memory to a particular element using calloc, malloc, all of those things. So same thing we're using here. We're using struct, that's the type, and then node, and then this pointer, star sign, asterisk, basically, then malloc, then size of struct node. Then we're going to say pointer data equals item. Make the link part of the new node pointing to the existing first node of the list. This will be done using following statement. So now we are pointing the head to this particular element. Okay, pointing next equals head. Then at the last, we need to make the new node as the first node of the list. This will be done using following statement: head equals ptr. Okay. Okay, so just recapping this part. So initially, this will be held inside of head. Okay, so if you notice here, what we're doing is this: we are making this ptr next value equal to head. Why? Because at this point, head holds the value of this node. Okay, so by setting this next value becomes this address. Now at this point, now head doesn't have any value, or actually it does have a value, but it has the old value, so you have to update the value pointing into the new node. So that's what's happening here. So this step that you see over here is here, and this step is this one. Okay, so algorithm is if ptr equals null, right, overflow, go to step 7. So if pointer is null, then we say it's overflow, and then go to step 7, which is exit. Then set new node equals ptr. Okay, so we create a new node at this point. We set it equal to ptr. Then we set ptr equals ptr next. Okay, then we say new node data equals the value. So we set the data of this new node to whatever value we want to set. Then we set the next, which is this guy here, to pointing to the head, because head contains the value of the old node. And then we set the head to the new node. So now we set the head to the new node, and then finally we exit. Okay, so that's your algorithm. I think we should stop here today. I'm going to end the
Yeah,
broadcast, and I guess you need some help from Sumaya.
yeah, yeah.